Hello everyone, my name is Moeen and I am a PhD at Data Driven Software Engineering Department at Simula Research Laboratory, Norway. And the paper that I am going to present titles Adaptive Immunity for Software Towards Autonomous Self-Healing Systems. Testing and code reviews are known techniques to improve the quality and robustness of a software. Unfortunately, the complexity of modern software systems makes it impossible to anticipate all the possible problems that can occur at a runtime, which limits the scope of testing and code reviews. Therefore, it is important to consider autonomous self-healing systems which can overcome these limitations. So, what is the definition of a self-healing system? It is defined by Ganak and Corby in a 2003 paper titled The Dawning of the Autonomic Computing Era, stated as systems that discover, diagnose, and react to disruptions. For a system to be self-healing, it must be able to recover from a failed component by first detecting and isolating the failed component, taking it offline, fixing or isolating the failed component, and reintroducing the fixed or replacement component into service without any apparent application disruption. In short, autonomous self-healing software systems can automatically detect, diagnose, and contain unanticipated faults at runtime. There are two approaches to achieve self-healing systems: model-driven approaches and data-driven approaches. The majority of the research in this area comes from the model-driven approach, where actual behavior of a software is checked against a formal model that specifies its behavior. The controller takes action when the system behaves different from its specification. One drawback of this approach is that it is challenging to develop such models for large and complex systems. Keeping them up to date as the system evolves is also a big challenge. With the recent advancements in machine learning, it is possible to learn such behavioral models through the data. Data-driven approaches can make use of techniques like artificial immune systems and other machine learning methods. Here in this picture, you can see two systems. The green part represents the system that is being managed, and the yellow part represents the controller. A controller uses the knowledge of the managed system to perform its function. The controller gathers the sensor or log data of the managed system. There are multiple components of a controller. Monitor gathers the data that exposes the actual behavior of the system. Analyze would detect if observed behavior violates the desired behavior. Plan would make the strategy to contain the fault. Both analyze and plan are part of the diagnosis. Execute would enforce the intervention to contain the violation, and thus the feedback loop would continue to work. Artificial immune systems are a machine learning paradigm inspired by the principles and processes of biological immune systems. AIS are adaptive self-learning systems that can learn normal patterns and detect the emergence of abnormalities. There are different types of AIS algorithms. First, we will talk about immune response models. Immune response models like negative selection algorithm work well with anomaly detection and diagnosis. The second ones are clonal selection algorithm. Clonal selection algorithms are focused towards multi-objective optimization problems. The third one is immune network algorithms. Immune network algorithms follow more complex interactions that allow for solutions to problems like classification, clustering, and optimization. And the last type are the hybrid approaches. Hybrid approaches enhance AIS with techniques like fuzzy set theory, Bayesian inference, information theory, or ensembles of AIS with other machine learning paradigms. To check more about the functionality and applications of AIS in different domains, please check the paper. In order to make a self-healing system using AIS, we propose a MAPE-K feedback loop-based architecture. This uses the immune response model of AIS. Here, knowledge is the representation of the problem domain that fits the AIS paradigm. A common representation can be a collection of antibodies, and each antibody is a tuple consisting of matching conditions and actions. And antibodies have weighted connections to each other, which are called as affinity. The monitor acquires data from sensors and it encodes it for machines in analysis phase. Analysis aims to recognize pathogens or anomalies by computing an antibody concentration metric based on the data acquired and the matching conditions and affinities of the antibodies. Planning. Planning selects the antibody that has the highest concentration in the acquired data. And finally, execution responds with the action corresponding to the selected antibody. The feedback loop makes the system adaptive and it can learn how to react strongly to anomalies and less strongly to the normal behavior. Following are some directions where data driven self healing based on AIS can be useful. Monitoring managed systems, anomaly detection, fault diagnosis, fault recovery, and evaluation of self healing systems. We developed research questions related to each direction with some possible candidate solutions to look into. In the next slide, we will look at some of those questions. Please check out the paper for more details. So, some of the important potential research directions are: what kind of observational data is needed for anomaly detection? To what extent can we learn models of normal behavior purely from runtime observational data? Can we successfully recognize anomalies in a system that is being evolved and therefore changes behavior? What are effective techniques to investigate and identify the root cause of a defect of a detected anomaly? How and at what scale can realistic fault scenarios be modeled and executed to enable effective and repeatable evaluation and validation of self-healing technology? To conclude, there is a need for more research on data-driven self-healing systems with the focus on artificial immune systems. We have learned that the complexity of modern software-intensive systems makes it difficult to anticipate all possible problems. Self-healing systems are designed to automatically detect, diagnose, and contain unanticipated problems at runtime. Artificial immune systems are well suited for building self-healing software systems because of their inherent focus on anomaly detection and diagnosis. Here are my contact details. Please feel free to contact me or ask any questions. Thank you so much for listening to the presentation.